Welcome to Cybersecurity Tutorials. This tutorial is the second part of behavioral biometrics for user authentication schemes. It focuses on behavioral biometrics modalities that can be used for user authentication schemes. Alright, let's begin the tutorial. Hand movements can be defined as a finite trajectory in 3D space for gestures like hold action, downward motion, or snapping action. To perform an activity like a sign into an IoT application on your smart device. Hand movements generate a unique user identification signature that can be registered in terms of X, Y, and Z coordinates. By using various sensors such as accelerometer, gyroscope, magnetometer or gravity sensors. Each sensor provides X, Y, and Z coordinates for the trajectory. You can calculate the magnitude stream using the formula shown in the slide. Afterward, statistical features can be extracted for each raw streams. Examples are given in the slide. Okay, let's refresh statistical features mentioned in the previous slide. Mean is the sum of individual scores divided by the number of individuals. Standard deviation indicates how widely individuals in a group vary. Skewness is a measure of symmetry, or more precisely, the lack of symmetry. A distribution, or data set, is symmetric if it looks the same to the left and right of the center point. Kurtosis is a measure of whether the data are heavy-tailed or light-tailed relative to a normal distribution. Voice biometrics exploits voice patterns to generate unique identification for a person. Human speech generation involves lungs, vocal cords, and vocal tract that include throat, mouth, tongue, nose, teeth and lips. When someone exhales, air is expelled from the lungs, and then passes over the vocal cords, which dilate or expand allowing the air flow to produce unvoiced or voiced sound. Which is then resonated and reshaped by the vocal tract that consists of multiple organs such as throat, mouth, nose, tongue, teeth, and lips. The vocal cords' modulation, interaction and movement of these organs can alter sound waves and produce unique human sounds. Pitch detection can be referred to fundamental frequency estimation. A phoneme is the smallest distinctive unit sound of a language. Each phoneme sound can be viewed as air waves produced by the lungs, and then modulated by the movements of vocal cords and vocal tract system. Voice-based authentication system can be both text-dependent and text-independent. Some characteristics of speech are pronunciation, pitch, speed of speech, speech emphasis, and accent. Voice recognition is a challenging task as speakers may have different accents, pronunciations, styles, word rates, and emotional states. Widely used voice features for user authentication are MEL frequency cepstral coefficients or MFCC. MFCCs are analogous to vocal tract in the source filter model of speech. Speech signal represented as a sequence of spectral vectors. Hidden Markov models implicitly model these spectrograms to perform speech recognition. CNN and DNN-based approach using acoustic features like cepstral coefficient. And Gabor filter-based features. GF is a transform-based method for extracting the texture information. Similarly, for phoneme, time difference of arrival. In the next slide, you will see the MFCC feature extraction method. MEL frequency cepstral coefficients or MFCC are coefficients that are derived from a type of cepstral representation of the audio clip. Here in the example, you can see voice signal containing two channels sampled at 44,100 Hz with 16 bits per sample, which is first filtered using a bandpass filter for improvement in signal-to-noise ratio. Fourier transform of a window of the voice signal is performed. Then scaling of frequency axis to the nonlinear MEL scale using triangular overlapping windows is performed. The frequency bands are positioned logarithmically, which approximates the human auditory system's response. Next, discrete cosine transform is performed on the log of the power spectrum of each MEL band. The MFCCs are the amplitudes of the resulting spectrum, which is 2D vector of size 13 cross variable length. The length of vector depends on the voice signal duration. Statistical features for each MFCC vector can also be computed. The behavioral biometrics exploits single footstep of a person. The footsteps recognition is based on the study of signals captured from persons walking over a sensing area. Rodriguez performed a footstep biometric assessment on their collected stride signals by using floor-based piezoelectric sensors. Edwards extracted geometric and wavelet features from the same footstep dataset collected by Rodriguez. Joe used a fabric sensor to record the user's footsteps. In the next slide, you see the feature that can be extracted from a person's footstep pressure data. From the left and right footstep pressure amplitude collected from the pressure sensors. Statistical features like spatial average, ground reaction force, upper and lower contours can be extracted. You can extract statistical features such as min, max, mean, standard deviation, skewness, and kurtosis, from each time series array. Also, the ground reaction force per sensor for left and right footsteps using formulae shown in the slide. Gait recognition is based on the study of the way persons walk. Persons' limb movement patterns can be used for their recognition. Typically, a gait cycle consists of two primary phases: the stance and swing. The stance phase consists of the entire time when a foot is on the ground. The swing phase consists of the entire time when the foot is in the air. In the next slide, you will see the various temporal and spatial characteristics that can be computed for a gait cycle. For a gait cycle, stance phase can further be divided into initial contact and loading response, mid-contact and terminal response, and pre-swing. Similarly, the swing phase can further be divided into initial, mid and terminal swing. Some of the time parameters for a gait are duration of step, stride duration, stance phase, swing phase, and cadence. And spatial parameters are stride length, step length, stride width or base of support, internal or external angle, speed and walk ratio. I hope you enjoyed the tutorial. If you have any question, please write a comment. Thank you for watching the video. Please subscribe to my channel and like the video.